What's up, home skillet biscuits? Today we're going to learn about one of my favorite liquids ever, and that's dihydrogen monoxide. So before I go into why water is so cool, I am going to talk about some vocabulary terms that we need to know for our sports drink and solutions unit. The first term is actually a term that we've already learned about. It's called polar and nonpolar. So if you can try and go back and think, what did polar mean and what did nonpolar mean when we learned about them? You might have no idea, but if you have an idea, you might be thinking of the word charged. Because we talked about that last time. We talked about it last time, how polar things are charged, basically like ionic compounds, okay? And nonpolar things were not charged or non-charged. Okay, so polar is charged, nonpolar is not charged. And why does that have anything to do with our unit? Well, things that are charged, if I mix a liquid that's polar, okay, if I mix a liquid that's polar with a solid that's polar, they will mix together and they will dissolve. They'll mix. If I take a liquid that's polar and I mix it with a solid that's nonpolar, something that's nonpolar, they won't mix together. It's kind of like oil and water. Think of polar things as being like the water, okay? And think of nonpolar things being like oil. Okay, water and oil don't mix, and the reason why they don't mix is because polar things will only dissolve with polar things, and nonpolar things will only dissolve with nonpolar things. That's where we get this phrase. Really, it's like the motto for dissolving. This is our motto. Like dissolves like. That's kind of a silly motto, but basically it means things that are like each other will dissolve together. So polar and polar things will dissolve, and nonpolar things will dissolve together. But if you take something that's polar and something that's nonpolar and you try to put them together, they're two different things and they will not dissolve in each other. Polar and polar dissolve, nonpolar and nonpolar dissolve, but they don't mix together, okay? So polar plus polar, yay, they dissolve. Nonpolar plus nonpolar, yay, they dissolve. But if you take a polar and a nonpolar, they will not dissolve, okay, because they're not like each other. So when I talked about how polar things are charged, I want to talk a little bit about why something is polar versus why something is not polar, okay? And that's when we're going to bring up another term that again, this is a term we've learned before, but it's called electronegativity, okay? That's the strength to steal electrons. If something really wants an electron really, really badly, we say it's electronegative. If there's a substance that doesn't want an electron, we say it's not electronegative. So let's take a look at water, for example. Water is H2O, okay, H2O, meaning there's two H's and one O. So let's say the H's are red, okay, and then the oxygen's white. And oxygen and hydrogens are a little bit more positively charged. Remember, they have a positive 1 charge, and oxygens have a negative 2 charge, okay? So what polar means is, polar means that one side of a molecule is slightly charged. So even though this whole compound's neutral, this oxygen side happens to be more negative than the hydrogens. So this is a more positively charged side of the water molecule, and this is a more negatively charged. So basically, you can see that even though our molecule's neutral, we have areas where we're more charged. Some areas are more charged than other areas. So there's 3 other terms I want to introduce here, and that's solution, solute, and solvent. They get really confusing because all 3 sound exactly like each other. A solution is going to be the mixture, okay? So it's the complete mixture. Once the 2 things are mixed together, we call this the solution. So this whole beaker here is the solution. Not the solution to our problems. Bad joke. Okay, solute and solvent are the 2 parts of a solution, okay? So these are both parts. This is part A and this is part B. And when they mix together, Part A and part B both form the solution when they're mixed together, okay? So the solute is the actual solid particle that is being dissolved. Okay, it's the thing that we are dissolving. Okay, the thing we're dissolving, the thing that's being dissolved. The solvent is the liquid, usually it's a liquid, that your solute is dissolved in. The most common solvent that we use in chemistry is water because it's awesome at dissolving things. It's like the coolest thing ever. A solute, the solid particle, that could be salt, that could be sugar, that could be lemonade powder, cocoa powder, anything that we dissolve in water would be considered the solute. So the particle is solute, the liquid is the solvent, okay? And then the solution is both of them together, mixed together. That's the solution. So the last thing I want to talk about is a particular type of solution, and that's any solution that has water in it. Any solution that has water as the solvent is considered aqueous. Okay, remember dissolved in water? We talked about that a couple units ago. Aqueous means dissolved in water, any solution that has water in it. Okay, so what I've done is I've given you a background of some key terms that you're about to hear in a video made by Hank Green, who is actually John Green's brother. John Green's the author of many famous teen fiction novels, such as the one that was made into a movie. I can't remember the title. I don't even know. But please go ahead and follow along with his video and fill in all of the questions that are bullet pointed under the Why Water is Cool section.
It falls from the sky. It makes up 60% of our bodies, and just about every chemical process related to life takes place with it or in it. Dihydrogen monoxide. Without it, none of the chemical reactions that keep you alive would happen. None of the reactions that sustain any life form on Earth would happen. Not even the majority of inorganic chemical reactions that shape the surface of the Earth would happen. Water is the key to nearly everything, and one of the reasons it's the key is because it's really good at dissolving stuff. We need it so bad that we dump over 180 gallons of it into our bodies every year, and we do that in order to maintain an aqueous or water-based solution inside our cells, because aqueous environments are pretty much the best for cool chemistry. Each and every one of us uses water for all kinds of chemistry every single day. Our body chemistry, our food chemistry, and yes, our laundry chemistry all take place in water. Ugh. This used to be a white sock. It is now a little bit of gray sock, and in places a little bit of a yellow sock. But anyway, I want it to be white again, and to do that, I'm gonna need some chemistry. To whiten whites, you might use a solution of sodium hypochlorite, better known as bleach. What makes bleach so good at its job is that it's a really strong oxidizer, meaning that the oxygen atom is really good at pulling electrons away from other compounds, making them break apart. This is really handy for getting rid of stains, but as you can tell by the formula, sodium hypochlorite also contains chlorine, which happens to be really good at killing things. That's why we use it in swimming pools and as a disinfectant. But there are lots of other good oxidizing agents, and one that doesn't contain chlorine is hydrogen peroxide, and it can be used as a bleach too, but its only components are hydrogen and oxygen, just like water. We'll talk about oxidation and other kinds of reactions in a couple weeks, but before we get to that, you have to understand solutions. And before we do that, I'm just gonna get rid of the laundry because it's kind of stinky. This bottle of hydrogen peroxide contains a solution. And not just the solution to my problem of stained laundry. By solution, I mean a solution of liquid with another substance dissolved in it. Here, water is the liquid or solvent, and hydrogen peroxide is the solute or dissolved material. And water is an amazing solvent, possibly, arguably, the best solvent on Earth. Why? A lot of reasons. There's a lot of it on the surface of the Earth. That helps. Just abundance is good. It's liquid at a very wide range of temperatures, and being liquid is what you need to be able to be a solvent. But also because it's polar. It's a very polar molecule. Remember how I said that oxygen is really good at pulling electrons toward it? Well, oxygen atoms are more electronegative than hydrogen. The oxygen atom pulls harder on the molecule's electrons than the hydrogen does. As a result, the electrons in a water molecule tend to spend most of their time near the oxygen, giving the oxygen end a partial negative charge and the hydrogens a somewhat positive charge. This polarity makes water extremely effective at dissolving things, especially other polar things. The sugar we mixed into our tea last week, for example, was polar. When you mix a polar solid like sugar into a polar liquid like water, the molecules of the water surround the sugar molecules. The negative side of the water molecule is attracted to the positive side of the sugar molecule and vice versa. In interacting with the sugar molecules, the water inserts itself between all of the individual molecules of the sugar that were once clumped together in the sugar crystals. A liter of water can dissolve as much as 1,800 grams of sucrose. Water-based solutions. Earlier I called them aqueous solutions, and I'm calling it an aqueous solution again so that you remember it's called an aqueous solution.
So I want to add on a couple things that Hank Green did not talk about with water and why it's so cool. One thing that I love about water is its density. The density of water is always 1 gram per milliliter. And we're not going to do a whole lot with that this unit, but it's good to know that the density of water is always, always, always 1. So if something is more dense than water, it will usually sink, and if something's less dense than water, it will float. So density of water is 1. A couple other things I want to talk about are some terms that you're going to be using in our project. One is called dissolution. One is called solubility. And then one is called dissolving. Okay, all of these terms mean the same thing. They're terms for the same thing. They basically mean dissolving, okay? If I say, what could you do that can make something dissolve faster? You might say like stirring, right? Another way I could ask that same question is I could say, how could you make something increase in dissolution? Increase in dissolution. I'm asking you the same thing that I did a second ago. Dissolution means dissolving. So what's a way I could increase dissolving? You could still say stirring, right? And last thing is solubility is the ability to dissolve. Okay, solubility sounds like ability, so it's the ability to dissolve. Same thing, they all mean the same thing. So if I say, what's a way we could increase the solubility of something? I'm talking about what's a way we could increase the dissolving ability of something, okay? So dissolution, solubility, dissolving, they all mean the same thing. They all mean dissolving. Drink deep. And that is it for 12.1. I hope you enjoyed learning about why water is so darn cool. Drink up and stay hydrated.